All right, you guys, I'm going to try to go through this pretty quick. This should help you on page 2. I'll even write it here just in case my voice doesn't come out. Well, page 2. Maybe that's just the back side of the front page. And there's some properties of exponents that we're going to go over. So these are some properties of exponents, and you'll find all of these somehow mixed in on page 2. So the one you learned the first, probably back in 6th or 7th grade, is how to add like terms. When you add like terms, you're looking for coefficients, like that has a coefficient of 1 and 2 and 3, but what you're really looking is to make sure the variables are the same. Well, these all have a variable of x, but those variables also have an exponent of the same. So 1x squared and 3x squared are like terms, and in this situation, since you're just adding, you can add 1x squared and 3x squared to get 4x squared plus 2x. And that's probably the simplest property that we have, but it gets confusing trying to mix this in with all these other properties. The first 3 are really the only ones that you need to know. One is product of power. Product meaning you're multiplying the same base with different exponents, so product of powers, right? You have powers right there. If I just broke this down, x squared is just x times x, and x cubed is x times x times x. So really all we're doing is we're counting how many x's are there. So what I really get is x squared plus x cubed as an exponent. We could see if I wrote this shorthand, I would get x to the 5th power. So product of powers is when you keep the base and you add your exponents. All right. Power of a quotient is very, very similar. If I wrote this longhand, that's x to the 4th. There would be 4 x's on top and 2 x's on bottom. So when you do quotients of power, kind of the opposite of what you did with product of power, you keep your base and you subtract your exponent. In this case, we give you x squared, which we can see that's remaining right here. Now, power of a property, if I wrote this out, there's 4 of these. 4 of these. So if I wrote it out, I would have x cubed times x cubed times x cubed times x cubed. And I could treat this very similar to I did the powers up here. I could say, hey, that's x, x, x. And all of these would just be 3 x's, right? So what we can see happening is those 4 groups, right, of 3 x's give me, well, the equivalent to x 3 times 4. 12 of them. And I'll put it in parentheses like this. So with this, you keep your base and you multiply your exponents. That's the power of a power rule, which gives you x to the 12th power. Really, that's all of them. All right, these 2 down here just allow you to bring in power of a products. Just says, hey, whatever's in there, we're going to take x squared to the 3rd power, and we're going to take y cubed to the 3rd power, which would give me x to the 6th times y to the 9th. And really this is just using this power of a power to bring in this 3. Quotient of the power is also using this power of a power, and that would be x to the 2 times 2 over x to the 3 times 3, which would give me, keep the base and add, now we're multiplying, right? We got x to the 4, x to the 9th. Oh, I apologize for that little spit. I'm not me making this movie. We did power of a power there. And now this is a quotient of power, so it's not keeping the base and add, it's keeping the base and subtracting. You know what, I could just kind of reduce and leave it on the bottom, but I want to show you something else. If I did x to the 4 minus 9, this would give me x to the negative 5th. And anytime you have a negative exponent moves to the bottom and turns into a positive exponent. I have shown you the reason why to this, but I'm just trying to do a really quick video. I want to add one more thing, that anything to the 0 power, anything to the 0 power is equal to the same number, the number 1. All right, I'm going to do one thing. I'm going to find the page that you're on. You should be on this page right here. All right, and I'm going to do one problem on this page, and then I'm going to post this. Let's go ahead and pick this problem at the bottom right here. All right. So the first thing I'm going to do is I'm going to bring this exponent into everything. All right. So we got our quotient of powers going here. And that would give me a to the negative 20, y to the negative 10. So that's negative 2 times 10, negative 2 times 5. All right. over a to the positive 6 and y to the negative 16th. Now, I'm going to do something a little bit different here. I'm going to take everything that has a negative exponent and I'm going to move it. That negative 20 is going to come to the bottom as a positive 20. That negative 10 is going to come to the bottom as a positive 10. That a is going to stay down here. It's positive. It's going to stay on the bottom. That y is going to move to the top as a 16. My a, that's product of powers. I keep the base and I add 20 and 6 and get 26. Quotient of powers, I keep the base and I subtract and get y to the 6. That's 16 minus 10. I'm going to pause there and post this. I hope you guys are having an awesome summer.